back to Try Hack Me Dojo and welcome to SEC-1 certification series. So in this today's video, we will be learning about IP addressing and subnetting. So without any delay, let's start with our today's video. So let us understand IP addresses with a short example or real world resemblance. So how does Zomato or Amazon deliver products to your exact home? Because every location has an address. Similarly, every device on a network has an IP address. So why IP address matters? Every device needs a unique identity. IP addresses act as identity, location, and communication. No IP knowledge is equals to no hacking skills. So let us understand what is an IP address. A logical identifier assigned to a device, or we can say an internet protocol or a numerical label assigned to each device on a computer network, which serve the two major purposes. First one is the host identification and the location addressing. Think of it as a postal address for your device on internet or a local network. Now let us understand about types of IP addresses. So we have two types of IP addresses, that is IPv4 and IPv6. IPv4 is a 32-bit IP address with a 4.3 billion addresses, and IPv6 is 128 massive space, or we can say hexadecimal in format. Most real-world systems still use IPv4 addresses. IPv4 existed, IPv6 exists because IPv4 addresses ran out. The internet grew beyond 4.3 billion devices. That's the reason IPv6 came into picture. So then comes the type of IP addresses, that is public, private, static, dynamic, and loopback. So public addresses are the type of addresses which are visible or facing towards the publics. So we can say, and it is an IP address assigned by internet service provider, visible over the internet. You can say your home router to external space. Then comes the private IP, used inside a local area network, not routable on internet, but it ranges are 192 to 168 dot something something. Then comes the static IP, manually configured, never changes, used for servers, routers, printers, and infrastructure. Dynamic IP, auto assigned by the domain host configuration protocol, changes over time. Most home devices uses this loopback address 127.0.0.1 points back to your own machine, used for testing and troubleshooting. Now let us have an understanding about IP ranges. So first is the private IP ranges, that is 10.0.0.0 slash 8. Then comes the class B. One class A consisted of 1 crore 67 lakh 77,216 hosts. Then comes the slash 12, which is the class B, 10 lakh 48,576 hosts are possible. Then comes the class C, which is mostly commonly used in our everyday life, or we can say the IP addresses provided to our devices. That is, it consisted of 65,536 hosts. These IPs are not non-routable. They cannot be directly accessed from public internet, perfect for internal reconnaissance. So introduction. So next topic is subnetting. Subnetting is the process of dividing a large network into smaller, manageable small networks. Each subnet operates as its own network segment. So why do we need subnetting? So basically it improves network performance, reduces the broadcast traffic, enhances security isolation, efficient IP utilization. So how it works? Takes a larger network block, borrows bit from host portion, creates a smaller network IDs. Each subnet has own broadcast. So what is the hacker's perspective? Reveals the internal structure, identify network segment, target specific subnets, and plan the lateral movement. So let us understand something more detailed about the subnet mask. So let us take an example of 255.255.255.0, where first octet, which is 255 is the net. First three octet is the network part, and the last octet is of the host part. The 255 octets or 255 is a subnet mask means all bits are ones. This means identify the network portion of the address. The 0 octet. A 0 is a subnet mask means all bits are zeros. This bits identify the host portion available for device. Mapping to /24. Count 1 bit 8 plus 8 plus 8 plus 0, which is 24 bit. So 255.255.255.0 is equals to /24. The CIDR notation is just the count of network bits. Now let us understand about the CIDR, classless interdomain resolution. So these are the notation used for understanding the networks and subnet mask and how many usable hosts is possible. So /8 tells us that there are 16 crore 77,724 usable hosts can be taken. /16 tells us that 65,534 hosts are possible. /24 tells us that 254 hosts is possible. 8/28 14 hosts are possible. /13 2 and /32 only one host. IP classes overview. There is, as I have previously mentioned, there are different class. We have classified it into IP addresses into different classes. That is class A, B, C, D, and E. Class A starts from 1 to 126. Class B, which is used by large enterprises and internet service providers. Class B starts with 128 to 191. Used by medium organization or universities. Class C 192 to 255. Used by small network or home local area networks. Class D 224 to 239. Multicast groups. Class E reserved for research and experimental purposes. Now let us understand network IP address into a smaller in detail manner. So 192.168.1.0 is the network address. It identifies the network itself, cannot be assigned to host. 192.168.1.255 is the broadcast address, which is used to send data to all devices in the subnet, not assignable. First usable IP 192.168.1.1. Usable IP address assigned to default gateway routers 192.168.1.254. Last word address before the broadcast address. So total usable hosts are 254 hosts. How hackers use the IP knowledge? They use the Nmap tool. First one is the network scanning. Tools like Nmap scan entire IP ranges to discover the live host. Knowing the subnet tells you exactly which IP address to clean. Target identification. IP addresses reveals server roles, web server, databases, gateways. IP plus port is equals to attack surface. Internal versus external. Private IPs is equals to inside the network. Public IPs is equals to internet facing attack surface. Crucial distinction. So here is some example of Nmap command. Nmap-SN 192. It helps us give and identify the live host within our network. And if we want to perform a port scan, through this port scan we will be getting know which are the ports open at the uh, within the network, or we can say host machine. Through this we can get an idea which open ports, and based on the open port we can perform some attacks. And in order to identify the host operating system of the host machine, we can use this nmap command, nmap-o. Aggressive scan, that is nmap-a. It gives us everything above of that is it gives live host, full port scan, OS detection if we perform an aggressive scan. Security perspective. What First one is the IP spoofing. Attackers post the IP addresses in the packets to impersonate another devices, bypass IP addresses, controls, or hide their true identity during attacks. Reconnaissance. Using IP ranges and CIDR notation, hackers map an entire organization network, discovering the servers, services, and potential entry point before attacking. Attack service mapping. Every discovered IP is a potential attack surface. Subnetting reveals which systems are grouped together, aiding privilege escalation and lateral movement. So what are the key takeaways from this particular today's video? First one is the IP, which we call it as an identity. Every device on the network has an IP address. It's the fundamental identifier used for all network communication and attack. The second one is the subnetting, which we call as control. Subnetting give divides the network for performance, security, and management. Understanding it reveals how networks are architected. Third one is essential for hacking. For reconnaissance to post to exploitation, IP and subnetting knowledge is non-negotiable for ethical hackers and penetration testers. Fourth one is know your ranges. Private IP ranges are your private IP ranges 10, 172, 192 are your internal network territory. Public IPs are your external attack surface. So what we will be saving in our next series of SEC-1 certification. So when we'll covering the ports and protocols, Module 4 will be DNS and HTTP deep dive. Module 5 will be practical network scanning. Thank you. Signing off. Stay secure. Stay curious.